Good morning. Yesterday we have seen the topic functions. In the class of last class we have seen the various definitions of function, and today we are going to see the types of functions. So, but before going to types of functions, once again recapture the definition of function. As per the definition of function, a relation from A to B, a relation from set A to set B is said to be a function if for all A belongs to A, for all A belongs to A, there exists a unique B belongs to B. There exists a unique B belongs to B such that f of A is equals to B. Such that f of A is equal to B, that means B is the image of A. So, this is the definition of function, and we have seen the various forms of the definition of the function in the last class, and this is also one more definition for the function. And now in the next class here we are going to see about the types of functions. Let us start doing the types of functions. So, we have various types of functions, and now we are going to see the first type of function called as one-to-one function. Say one-to-one function is also called as one-one function, or it is also called as injection. So, the very first type of function is going to be one-to-one function or one-one function or injection. Let us see about the definition of one-to-one function. Say f is a function from set A to set B. It must be a function from A to B. So, here I am taking a function from A to B, and a function from A to B is said to be a one-to-one function if distinct elements of set A. So, let us suppose that x1 and x2 are the two distinct elements of set A. Distinct elements of set A have distinct images in set B. Say the image of x1 under the f function is going to be f of x1. The image of x2 under the function f is indicated by f of x2. That is, if the elements are distinct, their images must be also distinct. That is, a function f maps A to B is said to be a one-to-one function if distinct elements of set A have distinct images. That is, this can be written as if x1 is different from x2, this should imply that f of x1 should be also different from f of x2. That means two distinct elements of set A need to have distinct elements of set B. That is, distinct elements of set A, if they have distinct elements of set B, then we can say the function is going to be one-to-one function. Or otherwise, we can also say that if the images are going to be distinct for two elements and the elements are also distinct, then we can also say that the function is going to be one-to-one function. Or otherwise, we can say that if two elements are having the same images, say f of x1 is equal to f of x2, that is, imagine that the images of two elements are going to be equal. That is, f of x1 is equal to f of x2. If this so happens, then the elements must be also equal, that is, x1 must be also equal to x2. Here, this is also we can say that in this case also we can say that the function is going to be a one-to-one function. Let us discuss this one-to-one function by using some example. Let us go through some example. Let us suppose that set A and set B are the two non-empty sets and f be a function from set A to set B. Here, imagine that we have got the elements 1, 2, 3, and here set B contains elements 4, 5, 6. Let us suppose that the image of 1 be 5, the image of 2 be 6, and the image of 3 be 4. If you observe carefully here, the distinct elements of set A are going to have distinct images of set B. So, we can understand that this particular function having different elements are having different images. So, this particular function is going to be called as a one-to-one function. So, So here we say f is 1-to-1 function, or simply we can say f is 1-1 function, or you can say f is injection. And let us go through some other example. Here, if I change, let's for example, if I take the image of 3, if I take the image of 3 as 6, image of 3 be 6, that is, here if you observe carefully, here the one image is going to be 5, that's not a matter, but here the image of 2 and image of 3 are going to have the same image, that is, distinct elements are going to have the same image, as because different elements have the same image, therefore this function is not a 1-to-1 function. So as per the definition, we need to see that distinct elements of the domain need to have distinct images in the codomain. So such kind of function we call it as a 1-to-1 function. Now the definition of 1-to-1 function finally is a function f maps a to b, a function, it must be a function from a to b such that distinct elements of set A have distinct images in set B. Is said to be a 1-to-1 function or 1-1 function. This definition can be also written in other way, that is, no two distinct elements, that is, a function f maps a to b, a function f maps a to b is said to be 1-1 function if no two distinct elements of set A have same image in set B. So finally we can conclude that if different elements of set A or if different elements of domain have different images in codomain, then we can say the function is going to be a 1-to-1 function. And we have got some alternate definitions for 1-to-1 function. Let us go through those also. Say here, this is going to be the main definition. So as per the main definition, we have got the property which we already discussed, that is, for all x1 comma x2 belong to A, x1 comma x2 belong to A, if x1 is not equal to x2, this must imply that f of x1 must not be equal to f of x2. So let us do some problem based upon this condition. Let's go to some example problem. Given f maps R to R is a function defined by f of x is equal to 3x plus 2. Now, is f a 1-1 function or not? So here sometimes a question would be asked in this manner, where the function domain and codomain are given and also the function rule would be given to us. Now based upon the domain and codomain and the function rule, we need to decide whether the function is going to be a 1-to-1 function. So first of all, whenever this kind of question is asked, you always have to think about what is the domain and codomain here. The domain is set of real numbers and the codomain is also set of real numbers. And he says that f is a function defined from R to R given by the rule f of x is equal to 3x plus 2. Now, because the set domain has got real numbers, it contains all the negative numbers and positive numbers. It do not contain only imaginary numbers. It contains every number like rational and irrationals also. So what I do is, let me just check for the image of 1. So based upon the rule, the image of 1 is going to be f of 1 is equal to 3 into 1 plus 2, that is going to be 5. So image of 1 is going to be 5. And if I want to find the image of 2, the image of 2 is given by the rule, the function rule is going to be f of 2 equal, the image rule is going to be f of 2. F of 2, it means it's going to be 3 into 2 plus 2. As 3 into 2 is going to be 6, 6 plus 2 is going to be 8. So check for some negative number. So if I take the image of minus 1, f of minus 1 is equal to 3 into minus 1 plus 2, that is minus 3 plus 2. Minus 3 plus 2 is going to be minus 1. So the image of minus 1 is minus 1. And the image of minus 2 is nothing but 3 into minus 2 plus 2. 3 into minus 2 is minus 6. Minus 6 plus 2 is going to be minus 4. So here we have tried a few examples taken from the domain. So it is very difficult to check for each and every number in the domain. So but we have made a trial with 4 numbers of the domain. And what we observed here is we observed that different elements are having the different images. So there is no chance that 2 different numbers are having the same image. So this should be done by observation. Once you confirm that the function is going to be one-to-one, because different elements are going to have the different images, because it's confirmed that it's going to have different elements is going to have different images, so the function is going to be one-to-one. Because it's going to be a one-to-one function, so obviously we can apply the property. So here for all x1 comma x2 belongs to a domain, let us suppose that x1 comma x2, let us suppose that x1 comma x2 be 2 elements from the domain such that x1 is not equals to x2, or f of x1 is equal to f of x2. You can use any of the properties what we have discussed earlier. So if I take the image of 2 elements are equal, let's check whether the elements are going to be equal or not. So f of x1 means f of x1 is nothing but equal to 3x1 plus 2, that is the image of x1 under the element and the function f is going to be 3x1 plus 2. Same way, the image of x2 under the function f is going to be 3x2 plus 2. Here, cancel out plus 2 and plus 2, we get 3x1 equal to 3x2. Here, cancelling of 3 and 3, we get x1 equal to x2. That means we have checked the property of one-to-one function, that is for 2 elements having the same images, the elements are also same. So we can conclude that f is going to be a one-to-one function, that is for all x1 comma x2 belongs to domain R, we observe that f of x1 equal to f of x2 implies x1 is equal to x2. Therefore, f is a one-to-one function. So this is the way how we need to solve a problem in case if they gave you the domain and codomain as well as the function rule. The problem can be in this manner, or sometimes the problem would be asked in a different way. Let's go with some other example. Let's take some example where the function is not going to be one-to-one. Say, given f maps R to R defined by is a function defined by f of x is equal to x square. So now they'll ask you, is f a one-to-one function? So the similar kind of question like before, but the function rule is changed to f of x equal to x square. The domain and codomain are also given to us. F is a function from domain R to R, codomain R, and the rule is given as f of x equal to x square. Now here we are supposed to check whether this function is going to be one-to-one function. Whenever such kind of question is given, always we need to try to take the arrow diagram and go with the observation. The domain here is R and codomain is also R. f is a function given by the rule f of x is equal to x square. Like in the previous case, if you observe carefully, in the previous problem, the function rule was a linear function, that is, it was 3x plus 2, it was a linear function. Observing carefully here, the degree of the term or the term in the rule is going to be second degree. So, in such a case, you try to observe carefully. Here, because the domain contains negative numbers as well as positive numbers, here also try to put some negative number and positive number and try to check whether they are going to have distinct images or same images. Because the real number contains negative numbers as well as positive numbers, that means always there is a possibility of taking same numerical numbers with opposite signs. So I do take 0 first. The image of 0 under the function f is going to be f of 0 equal to 0 square is going to be 0. So the image of 0 is going to be 0. Now let me check some number like 1 and minus 1. I take two numerical numbers, same numerical numbers with opposite signs. This will be always helpful for us to identify the function is going to be a one-to-one function or not. Observing carefully, the image of 1 is going to be f of 1 equal to 1 square, that's going to be 1. The image of 1 is going to be 1. The image of minus 1 is going to be f of minus 1 equal to minus 1 whole square. Minus 1 whole square is also equal to 1. That means here we observe that two different elements, 1 and minus 1, are having the same image. As because different elements are having the same image, you can confirm that this function is not going to be a one-to-one function. So whenever the function rule is given in such a way that every term is of second degree term or every term is of even degree term, then we have to be very careful that in that case there is a chance where different elements may get the same image. If different elements get the same image, the function will not become a one-to-one function. As here, not only these two numbers, you can take like minus 2 and 2. Observing carefully, the image of 2 is going to be 4 and the image of minus 2 is also going to be equal to 4. So by taking such kind of observations, we can confirm that or we can conclude that the function is not a one-to-one function. So here the solution goes in this way. In the function, here minus 1 and 1 belongs to R, that is they belong to domain. Because they belong to domain, we'll check for their images. The image of minus 1 equal to minus 1 whole square is going to be 1 and the image of 1 is also equals to 1 square, that is equal to 1 as per the rule. Therefore, what happened is different elements have got the same image as two distinct elements have same image, as two distinct elements have same image, therefore the function f is not a one-one function. If the function is not a one-to-one, it is enough to give some example why it is not going to become one-to-one. If the function is a one-to-one function, then we need to prove it by using the property like how we have done in the previous example. So the only tip you can remember here is, in case if the function rule is given as f of x square or some rule in which every term is of having the even degree term, every term is of even degree, then in such a case you have to be very careful, check for some numbers, same numericals with opposite signs and check their images. In case, if in this example, if I make some small change, that is in the domain, instead of taking the real number set, if I take the domain as some natural number set, then what happens to this problem? So in this case, if the domain is going to be a natural number, that means I am going to take the domain as set of natural number and the codomain is going to be a real number set, and f is going to be the same rule, f is going to have the same rule, that is f of x equal to x square. So even though the degree is going to be second degree, but the domain is going to be n, as because the domain is natural number set, it does not contain negative numbers. So we cannot take numbers like minus 1, minus 2 in this case, or can't take 0 here because domain does not contain these negative numbers. So there's only chance of taking the positive numbers. That means we need to always take only the positive numbers and try to get their images. So as per the function rule, the image of 1 is going to be 1 square, that's going to be 1, which is there in the real numbers. The image of 2 is going to be 4. The image of 3 is going to be 3 square is going to be 9. In this way, if you observe carefully, here there is no chance of getting negative number. That means you cannot pick two numbers having same numerical values but opposite signs. As because you cannot pick the same numerical numbers having the opposite signs, there's only chance of taking the positive numbers from the domain. So every positive number you take, their image is going to be different. So there's no chance of different numbers having the same image. So in this example here, if the domain is changed, so obviously the function is going to become one-to-one because different elements are going to have different images. So the entire problem depends upon the domain and the function rule. So whenever the question is asked to check whether the function is going to be one-to-one or not, you need to check these two things. One is the domain, the other one is the function rule. Observe carefully. By observation, you can understand whether the function is going to be one-to-one or not. If it is a one-to-one function, make use of the property and prove that the function is a one-to-one function. If it is not a one-to-one function, just give an example why it is not a one-to-one function and conclude your answer. So this is the example related to the property of one-to-one function. And let us go with the other definitions of one-to-one function. We have so far discussed the main definition of one-to-one function, that is, if f is a function from a to b, different elements of set A need to have different elements, different images in set B, and such kind of function is called as a one-to-one function. Now let us see the alternate definition of one-to-one function. So the alternate definition of one-to-one function. It happens that the one-to-one function or the questions will be not as like using the property. Sometimes they'll give the functions as ordered pairs and they'll ask you whether the function is going to be a one-to-one function. So in case if the function is given as a set of ordered pairs, that is say 1, 3, say 2, 5, 6, 7 or 8, 9. Yesterday we have seen whether a relation also is a set of ordered pairs. A relation is said to be a function if the first coordinates are all distinct. Here observe carefully, this is a set of ordered pairs and every ordered pair contains the first coordinate distinct. That means this relation is going to represent a function. Now because this is a function, because the first coordinates are all distinct, this is a function. As this is a function, now we need to confirm whether this particular function is going to be a one-to-one function or not. So whenever the question is asked in this way whether the function is going to be one-to-one function or not, observe the second coordinates. So when I observe the second coordinates, if the second coordinates are all distinct, then that particular function is going to represent a one-to-one function. If second coordinates are not distinct, the function will not be a one-to-one function. Let us see about why. If for example, observe carefully, this can be written in the symbolic form as f of 1 is equal to 3, that is the image of 1 under the function f is going to be 3 and the image of 2 under the function f is going to be equal to 5. The image of 6 under the function f is going to be 7 and the image of 8 under the function f is going to be 9. If I put the arrow diagram, say the domain and the range, if I put as say A and B, because the domain and codomain are not mentioned in the question, let me take them as A and B. And let me put